It's time for researchers to come. I am Nadi. In this program, we introduce the researchers from all over the universe. And today's researcher is Dr. Belal E BAAQUIE, Professor of Physics, National University of Singapore. Nice to meet you, Dr. BAAQUIE.
Pleasure's mine.
So, please explain your current research theme briefly.
I've been working on applying the mathematics of quantum mechanics and quantum field theory to finance, and currently I'm applying it to interest rates. And interest rates, as you may know, forms the bulk of the financial market and of financial instruments. Almost 70% of all financial instruments and of liquidity in finance is in the debt market, which is described by interest rates.
And your research field, quantum finance, is very new field. And could you explain the difference between the current finance system and quantum finance?
Currently in financial modeling, it's entirely based on what is called stochastic calculus and on partial differential equations.
So
Whereas, this is an example of that. If you look at the first line,
Okay.
that's the Black-Scholes equation.
Oh, yeah, it's very
famous
famous equation in
Yes,
finance.
yes.
Okay.
And if you look at the line below that, I basically rewrite that equation as an equation of quantum mechanics, and that's why I call it the Black-Scholes-Schrodinger equation, to remind the readers that the Schrodinger equation is a different formulation than simply stochastic calculus. It's a much bigger and broader formulation. And the basic idea of quantum mechanics is that there's an operator called the Hamiltonian, and there is a Hilbert space, which the instruments are described by elements of the Hilbert space. In this case, the state space. So I then take this idea and generalize it to the case of interest rates, which are much more complex and much more interesting also from a mathematical point of view. Because for interest rates, you need to describe it by what is called quantum field theory, which is a very powerful formalism in physics.
Okay. So let's talk about the second topic, what you can offer. So you are very unique point of view in interest rate. Could you tell me about more about it?
Well, my research for the last few years has been to show that interest rates are described by a two-dimensional quantum field, and this, I think, is my main point of view, which I think researchers would be interested in, because it's a unique point of view. So far, no one has seen the interest rates as a two-dimensional quantum field. And once you say that, it's a massive and a very far-reaching implications. The thousands of things are inherent in a quantum field, which slowly become obvious as you study it. And so, I've been finding new things all the time when I study them, interest rates. Now I've been studying LIBOR and Euribor, which are the interest rates for the euro and the US dollar. And all sorts of new properties are visible because of the quantum field formulation. So I think researchers would greatly benefit from this point of view.
Okay, thank you very much. So, what is your future research theme? Please tell me.
I've actually worked almost 10 years in developing and perfecting, in my view, or trying to perfect the application of quantum mathematics to finance. I think now, I'm just completing a second book, which is also published by Cambridge University, which I call Interest Rates in Quantum Finance. I feel I have developed the formalism to a point where now applying it has become my main focus. The test of all of the mathematics I do is ultimately the market. But the market will show this formalism has something new to offer or not. Otherwise, it's simply an interesting idea.
Okay. So, could you tell me why do you focus? Why do you are interested in finance?
That's an interesting question. I became interested in finance actually slowly through my interest in economics. Initially, I was interested in economics and how commodities are priced and how the pricing happens for traded for commodities in the market. But then I realized slowly that economics is a far broader and a far bigger place than finance. So finance is more empirical and more driven by mathematical models. So slowly, I then focus on finance and in particular options in finance as the place where mathematics has the most visible application and most, I would say, useful application.
And you, 10 years ago, you entered some business school and
Yes,
tried to
yes. I
study.
happened to be in for sabbatical at Harvard, so I used to actually visit my friends in the Harvard Business School
Mm.
regularly in 1998, and I learned a lot from them.
Mm.
And I am still in contact with them. See, one thing I realized, a lot of experts say that finance and financial, markets can never be mathematically described. There's a strong view,
Mm.
and they support the view by saying that look at the big crashes. No one can predict the big crash,
Mhm.
and hence all the mathematics you do can't avoid the crashes that are in some sense beyond any mathematical model. And my response is, that may be true. Okay, we cannot predict the big crashes, and the analogy is in nature, in earthquakes.
Mhm.
Earthquakes, no one can predict where the earthquake will
Mm.
happen. That doesn't mean that we don't study the dynamics of the Earth's surface and the plate
Mm.
movements to understand the nature of earthquakes.
Mhm.
Similarly, in finance, we may not predict the earthquakes, but that's a very rare phenomena.
Mhm.
In finance, in every day, literally trillions of dollars of instruments are traded,
Mhm.
and my focus is to price those instruments so that in the state of normal market conditions, I believe mathematics has a great role to play.
Mm.
Now, even when you have crashes, say if you have a big crash, even then, how the market recovers from the crash can also be modeled.
Mm.
So, I will not say that mathematics can solve all the problems of finance. No, maybe these big, rare events, which are very important, are beyond mathematics. However, there's a lot of places where mathematics can be used.
Mm.
And,
Yes.
I'm happy to work on that part of finance.
So it's very interesting. You are somehow changing the system of finance by using quantum finance or point of view. Thank you very much. So let's move to the last topic. In order to achieve your research theme, what you need, what kind of resource you need.
That's a very interesting question. Thank you for asking that question. Because, from the research point of view, just doing my papers and writing books, the university in Singapore has always supported me. And, I have, in fact, gotten tremendous support from my department and from my faculty. However, I think now the time has come for me to apply this to the world of finance, to the capital markets, and really that is a place where I certainly would welcome collaboration, because I feel now that my instruments need to be applied in collaboration with some investment banks.
Investment bank.
Yes, investment banks, because they are the ones who design and price these instruments that I have been studying.
Mm.
So, if I can collaborate with them, I could show the real power of the formalism without actually going to the market. As in physics, experiment shows you that you are correct. In finance, the market shows you if you're correct or not correct.
Mm.
So, to enter the market is a very practical consideration. And in that sense, if I can get a collaboration with an investment bank, I think that will be the final test for my theories.
Yes. Okay. So in physics you can do some experiment, but in this field you do experiment in real market
Yeah,
economy.
absolutely. That's the
Okay.
only place experiment will take place.
Okay. And you also need some student. I hear that.
Well, yes, I always welcome students who work with me, because, if you have students and collaborators in general, you can do many more problems. If I can do one problem alone, with 5 students, I can do 5 problems. And I'm also happy to see that the formalism that I have developed keeps on producing new results. That's very important, you see, because if the formalism comes to a dead end, that means it's not very deeply grounded. But in this case, what I found, wherever I apply the formalism, it opens new doors. And for that, I need more students or collaborators, because, the more doors you open, the more powerful the formalism is.
Okay. So thank you very much.
My pleasure.
Okay, so that's all of today's interview. So today's researcher is Dr. Belal E BAAQUIE, the professor of physics, National University of Singapore. Thank you very much.
Thank you.
So see you next time. Bye bye.